The angle of inclination between vectors p bar and q bar is theta. If p bar and q bar are interchanged in position, the resultant turns through an angle phi. Then find the correct option. Given 4 options. So first of all, the angle of inclination between two vectors p bar and q bar is theta. Let's draw the diagram. So there are two vectors. This is intersection point O. So suppose OA is vector p bar and OB is vector q bar. So here p bar and q bar are two vectors, and angle between p bar and q bar is theta, given angle theta. If p bar and q bar are interchanged in position, so this is case 1, and case 2, so here OA is p bar and OB is q bar. So here p bar and q bar are interchanged in position. So we have to interchange the positions of the vectors. Then what will be the diagram? So obviously this is OA and this is OB. So now OA becomes q bar. We have to replace p bar by q bar and q bar by p bar. So we have to interchange the positions of vectors p bar and q bar. Okay, now anyhow still the angle between p bar and q bar is theta. There is no change in angle. Okay, now so inclination angle is same. So angle between p bar and q bar is theta. But after interchanging the position, the resultant turns through an angle phi. Here resultant turns through an angle phi. Before that, now construct a parallelogram. So here we have to apply parallelogram law of vectors or forces concept. So let us consider OA and OB are two adjacent sides of a parallelogram. So these two are OB, suppose O, OA, OB, suppose this intersection point C. Here OBCA is a parallelogram, OB parallel to OC, AC, so obviously this will be Q bar, and OA parallel to BC and equal. This is P bar. So the diagonal represents, according to parallelogram law of forces or vectors, the diagonal represents resultant R bar. So here R is a resultant. Okay. Suppose let us consider a resultant makes an angle alpha with the line OA. Makes an angle alpha with the line OA. Here same, construct a parallelogram. So this is Q bar and this is P bar. Similarly, so in this case resultant R makes an angle alpha with the line OA or with the vector P bar. Similarly, here resultant makes an angle beta with the vector Q bar or with the line. So after interchanging the positions of the vectors P bar and Q bar, the resultant R makes an angle beta with the vector Q bar. So before interchanging the positions, resultant makes an angle alpha with the vector P bar. So in case 1, so tan alpha. So case 1 means before interchanging the positions of P bar and Q bar, vectors P bar and Q bar. So from parallelogram law of forces, tan alpha. Here tan alpha means angle made by resultant with a vector p bar. So tan alpha is equals to q sin theta by p plus q cos theta. Similarly, after interchanging the positions of p bar and q bar, so nothing but case 2. In case 2, tan beta is equals to, where beta is angle made by the resultant with the vector q bar. So tan beta is equals to, so we have to interchange the positions of p bar and q bar. So here q becomes p sin theta by, so q plus, instead of q, p cos theta. Even if you derive the relations for tan alpha and tan beta, you will get same equations. Anyhow, here tan phi is equals to, we already written tan phi is equals to tan of beta minus alpha. Beta minus alpha. So tan of a minus b. So tan trigonometry, apply trigonometry concept. So trigonometry concept, tan beta minus alpha. So tan a minus b formula. What is tan a minus b? Tan a minus tan b by 1 plus tan a tan b. So tan a minus b, tan a minus b is equal to tan a minus tan b by 1 plus tan a tan b. So where a is equal to beta and b is equal to alpha. So tan beta minus alpha is equal to tan beta minus tan alpha by 1 plus tan beta tan alpha. Now substitute the values. What is tan beta? So here tan beta is equals to p sin theta by q plus p cos theta minus tan alpha. Here tan alpha q sin theta by p plus q cos theta whole divided by 1 plus tan beta. So again tan beta is equals to p sin theta by q plus p cos theta, and here tan alpha. Tan alpha means q sin theta by p plus q cos theta. Substitute just the values of tan beta, tan alpha. Just simplify further. So it's somewhat lengthy but simple. Just we need to simplify further, that's all. You need to find simplest form, that's all. So just observe what is the common factor among these two terms. So here common factor is sin theta. Take out sin theta as a common factor and write the remaining expression. Okay, now sin theta is common. So tan phi is equals to sin theta is a common factor. So sin theta common, and remaining p by q plus, and the remaining expression p by q plus p cos theta minus sin theta common, so q by p plus q cos theta. So whole divided by denominator. So 1 plus, so product of numerators by product of denominators. So p into q, pq, sin theta into sin theta, sin square theta, whole divided by q plus p cos theta into p plus q cos theta. So product of numerators by product of denominators. Product of numerators by product of denominators. Okay. Simplify further. Let's simplify further. So tan phi as usual. LHS is same. Sin theta. So what is the LCM? So here LCM is Q plus P cos theta into product of denominators. P plus Q cos theta. So LCM is product of denominators. Okay. So these two are unlike expressions. LCM will be their product. So your denominator is P plus Q cos theta. Now multiply numerator with P plus Q cos theta. Your denominator is Q plus P cos theta. So LCM is Q plus P cos theta, P plus Q cos theta. So obviously your numerator is P. Now multiply numerator with P plus Q cos theta. Minus. Similarly Q into, here denominator is P plus Q cos theta. So we need to multiply numerator with Q plus P cos theta. Whole divided by, so here again it's like solving mixed fractions. So 1 into, here LCM is Q plus P cos theta into P plus Q cos theta. Now multiply with the numerator here. 1 into Q plus P cos theta into P plus Q cos theta. So 1 into Q plus P cos and P plus Q cos theta plus, here denominator is anyhow LCM, Q plus P cos theta, P plus Q cos theta. So obviously we have to multiply PQ sin square theta by 1. So anyway you will get same expression, PQ sin square theta whole divided by LCM Q plus P cos theta into P plus Q cos theta. Just elementary simplifications, that's all. So denominator get cancel. So Q plus P cos theta, P plus Q cos theta, and Q plus P cos theta, P plus Q cos theta gets cancel. And the reducer form. So after eliminating the denominators, we get this expression. Just simplify further. Sin theta into P, P square. So P into Q cos theta, PQ cos theta minus Q into Q, Q square. So minus Q into Q, minus Q square, minus Q into plus P cos theta, minus into plus, minus. So PQ cos theta, bracket close. This apply distributive property, Q into P, QP or PQ plus Q into Q cos theta, Q square cos theta plus. Now distribute P cos theta into P, P square cos theta, P cos theta into Q cos theta, PQ cos square theta. So PQ sin square theta. So distribute sin theta. P square sin theta plus PQ cos theta sin theta. Sin theta into minus Q square sin theta. Sin theta into minus PQ cos theta minus PQ cos theta sin theta whole divided by PQ PQ. So just to find the common terms. So here cos theta is common. In these two terms cos theta common. Take out cos theta. So cos theta common and remaining terms p square plus q square into cos theta. And so here PQ, here PQ is a common factor, PQ common, and the remaining terms cos square theta plus sin square theta. In trigonometry concept you already learned sin square theta plus cos square theta is equal to 1. So this expression becomes 1. So PQ into 1 PQ. Here one more PQ is there, PQ plus PQ, 2 PQ. So here plus PQ cos theta sin theta minus PQ cos theta sin theta get cancelled. So final expression P square sin theta minus Q square sin theta whole divided by 2 PQ plus P square plus Q square into cos theta. So this is the reduced form of tan phi. This is the final result for tan phi. Okay, but we need relation between tan phi, phi and theta. So still we need to simplify further. We didn't get the answer. So finally we come to this equation. Tan phi is equal to p square sin theta minus q square sin theta by 2pq plus p square plus q square into cos theta. We don't have this option. So we have to simplify further. So before that, in multiple angles, tan 2a is equals to 2 tan a by 1 minus tan square. So tan 2a multiple angles. In case of submultiple angles, suppose tan phi becomes, suppose if I consider angle phi, this is formula for multiple angle, like tan 2 phi is equals to 2 tan phi by 1 minus tan square phi. If I consider submultiple angle, so 2 phi off of this angle phi. Similarly RHS 2, for 2 phi we have phi. In case of phi we get 2 tan phi by 2 submultiple by 1 minus tan square phi by 2. Okay, in case of multiple angles, tan 2 phi formula 2 tan phi by 1 minus tan square phi. Okay, now so if I consider submultiple angle, suppose tan 2 phi off of the angle 2 phi, so obviously phi. So similarly in RHS phi becomes phi by 2, phi becomes phi by 2. This is the formula for tan phi. So in LHS we have tan phi. So instead of tan phi we can write 2 tan phi by 2 whole divided by 1 minus tan square phi by 2. So RHS, anyhow we have same RHS. P square sin theta minus q square sin theta whole divided by 2pq plus p square plus q square cos theta. So here writing tan phi by 2 every time is a difficult task. Let tan phi by 2 is equals to, let tan phi by 2 is equal to x. Okay. So this is an equation. So now apply cross multiplication. So 2, already tan phi by 2 x, 2x into this expression. So just apply distributive property. 2 into 2, 4 pq plus 2 into p square plus q square cos theta. So tan phi by 2 means x is equals to, again, cross multiplication, 1 minus x. Here tan square phi by 2 means x square. So here square is there. So x square. 1 minus x square. So 1 minus x square into this expression. Now apply distributive property. I am doing at a time. See. So 1 minus x square into this expression. So first distribute 1. 1 into p square sin theta. P square sin theta. Minus 1 into q square sin theta. Q square sin theta. Now distribute minus tan phi by 2 value x. So it becomes x square. Now distribute minus x square. Minus x square into p square sin theta. Minus x square into, so this is p square sin theta minus q square sin theta. So x square into p square sin theta minus q square sin theta. So 1 into p square sin theta minus q square sin theta, p square sin theta minus q square sin theta. So minus x square into this expression. Okay. Just apply cross multiplication. Just observe, it looks like quadratic equation. Here variable is x. Okay. Here unknown is tan phi by 2. We have to find tan phi by 2. Suppose let us consider our unknown is tan phi by 2. So anyhow here tan phi by 2 is equal to x. So this is, so highest power of this equation is 2. Square term is there. Here square term, x term and constant term. So this will be quadratic equation. So just write the standard form of quadratic equation here. Now write this equation into standard form of quadratic equation. First square term, transpose minus x square into this expression. Transpose x square term, negative becomes positive. So x square into, or you can write like this. First coefficient, right? Coefficient first, p square sin theta minus q square sin theta, and this is coefficient of x square. Okay. Next x term. Anyhow left hand side we have x term plus 4pq plus 2 into p square plus q square into cos theta. Okay. Into x and transpose constant term. So negative positive p square becomes negative p square, negative q square becomes positive q square, plus q square sin theta minus positive becomes negative minus p square sin theta is equals to 0. Okay, we transposed all right hand side terms. So now it becomes general form of ax quadratic equation, ax square plus bx plus c, this is constant, is equal to 0. This is general form of quadratic equation. So what is the solution for, what is the formula for finding solution of quadratic equation? Sridharacharya equation, Sridharacharya, that is x is equals to, what is the formula? X is equals to minus b plus or minus root over b square minus 4ac by whole divided by 2a, minus b plus or minus root over b square minus 4ac by 2a. So remember where x is equals to tan phi by 2. So phi by 2 means off angle. So off angles are always positive, remember. In trigonometry we already learned off angles are always positive. So here we have plus or minus sign. That's why we after while simplifying this equation or this formula, we apply only positive sign. We need not to consider negative sign. Why? Because off angles are always positive. That's why we consider only positive sign. Anyhow, what is A, what is B, what is C? So, what is the general form of quadratic equation? Ax square plus bx plus c is equal to 0. Here A means, here B means coefficient of x. So, coefficient of x means this expression. So, let us substitute all that. X is equals to minus b. So, this is b value minus b. So, here minus sign is there. Now, multiply with minus. I am writing direct steps. Minus into 4pq minus 4pq. So, minus into 2 into p square plus q square into cos theta minus 2 into p square plus q square into cos theta. So, minus b term completed. Plus, we are considering only positive sign because off angles are positive. So, plus root over b square. Here b means this expression. So, 4pq plus 2 into p square plus q square cos theta. So b square. So I will keep a bracket. So 4pq plus 2 into p square plus q square into cos theta b square whole square. So root over continuation, this is minus 4ac minus b square minus 4ac. What is the value of a? Coefficient of x square, where a is coefficient of x square, p square sin theta minus q square sin theta here c is q square sin theta minus p square sin theta. Minus p square sin theta. All divided by 2a. 2a into p square sin theta minus q square sin theta. Okay. So we have to substitute all values b, a, c. So this is b minus b value and root plus, we consider only positive sign because off angles are positive, plus root over b square. So b square means here b is equals to this expression whole square minus 4 a value, this is a, and into b c value 4ac, this is c. Substitute all values, whole divided by 2a. So 2 into again a value. This simplify further. Yeah, it looks a little bit clumsy, but here the space is not sufficient. So I just solve part by part. See, leave this expression as it is. So minus b, okay. Now I'm going to solve square root expression. I want to simplify square root expression. Only I want to simplify this part. Suppose this is part 1. So this is P1. This is part 1. 4PQ plus 2 into P square plus Q square cos theta whole square. And this is my part 2. P2. Okay. Just I want to simplify part 1 and part 2. Later we can substitute and we can simplify further. So anyhow, So I'm considering only part 1. Okay, don't get confused. So I'm taking only part 1. So part 1, here part 1 expression. Later we can implement square root. We can apply square root. First of all, let us consider that only the radian 4pq plus, so we'll write here part 1 p1. So part 1 expression 4pq plus, by solving part by part is very easy. Two into p square plus q square into cos theta whole square. So this expression whole square. Let me simplify further. So it looks like a plus b whole square. So apply the a plus b whole square formula. A square 16 p square q square, a square 4pq whole square 16 p square plus q square plus b square 4 p square plus q square whole square. So b square means 2 square 4 p square plus q square whole square. Similarly cos square theta. A square plus b square plus 2ab. 2 into 2 a value. Here a value 4pq into b value. So 4pq into b. Here b is 2 into p square plus q square into cos theta. So a plus b whole square, expand a plus b whole square. On using a plus b whole square, expand this expression. So a square 16 p square q square and b square 2 square 4 p square plus q square whole square cos square theta plus 2ab. 2 into a value 4pq, b value this expression. Just simplify further. 16 p square q square plus 4 into a, again a plus b whole square. See, p square plus q whole square. A is equal to p square, b is equal to q square. So a plus b whole square, a square p power 4 plus b square q power 4 plus 2ab. 2p square q square 2ab. 2p square q square. That's all. Into cos square theta. Next. So just multiply next. Just multiply 2 into 4, 8. So 8 into 2, 16. So 16 PQ okay. So 2 into 4, 8. 8 into 2, 16. So 16. Next PQ so PQ into P square plus Q square into cos theta. Okay. So just reduce further. So 16 P square Q square plus 4 into P power 4 plus Q power 4. 4 into p power 4 plus q power 4 plus 4 into 2, 8. 4 into 2, 8. 8 p square q square into cos square theta plus 16 pq into p square plus q square cos theta. 16 p square q square plus, so 4 into p power 4 plus q power 4 into cos square theta. 4 into p power 4 plus q power 4 cos square theta. So 8 plus 8 p square q square cos square theta plus 16 pq into p square plus q square into cos theta. This is the reduced form of part 1. Okay. So part 1 final expression. Now we need to simplify part 2 also. So this is part 2 expression. So part 2 expression means minus 4ac. So this is minus 4ac term. So minus 4a and c. Coefficient of x square constant term. So we have to simplify part 2 also. Part 2. So first of all, here let us take minus common. So if I take minus common, so positive becomes negative, negative becomes positive. Minus 1 common. Let us take minus 1 common. So if I take minus 1 common, minus 4 into minus 1 plus 4. Or otherwise you can simply distribute further, no problem. Or otherwise minus 4. If you are not comfortable with this, then simply distribute, no problem. P square sin theta into q square sin theta. P square q square sin square theta. P square sin theta into minus p square sin theta minus p power 4 sin square theta. Now distribute minus q square sin theta minus q square sin theta into q square sin theta minus q power 4 sin square theta. Minus into minus plus q square into p square q square sin square theta. Next, just distribute minus 4 p square q square sin square theta, or first of all p square q square sin square theta plus p square sin square q square theta minus 4 into, so 2p square q square sin square theta. Here one p square q square sin, here we have another p square q square sin square theta. So add, so you will get 2p square q square sin square theta. Next, here minus minus sin square theta common. So minus sin square, if sin square theta common means you will get p power 4, here p power 4, here q power 4 into sin square theta. Now distribute minus 4. So you will get minus 4 into 2 minus 8 p square q square sin square theta minus 4 into minus plus 4 into p square plus q, sorry, p power 4 plus q power 4 sin square theta. So minus 8 p square q square sin square theta plus 4 into p power 4 minus 4 into minus plus 4 p power 4 q power 4 sin square theta. This is the final expression for part 2. This is our final expression for part 2. This is part 1 expression and this is part 2 expression. Let's simplify further. Let us substitute these two expressions, part 1 and part 2, in Sidracharya equation. Okay. Now let us substitute part 1 and part 2 in Sidracharya equation, quadratic formula. Nothing but quadratic formula. So minus b as it is. So we consider plus or minus, actually plus or minus sign will come, but half angles are positive, we consider only positive sign. Root over, so minus b plus root over b square minus 4ac. So b square, so part 1, b square means here part 1, right, part 1, 16 p square q square plus 4 into p power 4 plus q power 4 into cos square theta plus 8 p square q square cos square theta cos square theta, okay, plus 16 pq p square plus q square cos theta. So this is b square part 1 minus 4ac term, this is minus 4ac term, minus 8 p square q square sin square theta plus so square root applied for all these terms, 4 into p power 4 plus q power 4 into sin square theta. So just identify the like terms. Just also like terms. Is there any like terms? 16 p square q square. Any p square q square term? No. Next. 4 into p power 4 q power 4 cos square theta. So cos square theta term p power 4 plus q power 4 cos square theta. But anyhow, here 4 into p power 4 plus q power 4. Here also 4 into p power 4 plus q power 4. So we can take 4 into p power 4 plus q power 4 common, and we get cos square theta plus sin square theta. Cos square theta plus sin square theta value 1. So here common factor is 4 into p power 4 plus q power 4, and cos square theta plus sin square theta 1. Okay. So minus 4pq minus 2 into p square plus q square cos theta plus root over 16 p square q square plus here 4 into p power 4 plus q power 4. So cos square theta, here also 4 into p power q power sin square theta. So 4 into p power q power 4 common. So you will get cos square theta plus sin square theta value 1. So final expression will be 4 into p power 4 plus q power 4. So okay, so these two terms already simplified. This one also completed. Next, we need to consider remaining terms. P square q square, here sir. So 8 p square q square common. Here 8 p square b, here 8 p square q square plus 8 p square q square common, and remaining terms here cos square theta minus sin square theta. Okay, so all terms comes under square root. 16 pq into p square 8, okay na, 16 pq into obviously last term this one only, 16 pq into p square plus q square cos theta. Okay, all terms, all divided by anyhow again same 2 into p square sin theta minus q square sin theta. At last we can simplify denominator. X is equals to minus 4pq minus 2 into p square plus q square cos theta plus square root of so we have to let's see it is possible to simplify further or not. So here ultimately we need to eliminate square root symbol. So here 16 p square q square plus 4 p power 4 q power 4 8 p square q square cos square theta minus sin square theta plus 16 p square plus q square cos theta. Here sine square theta can be written as 1 minus cos square theta. So write remaining term 16 p square q square plus 4 p power 4 plus q power 4 plus 8 p square q square. So cos square theta, so sine square theta. So sine square theta can be written as, here sine square theta can be written as 1 minus cos square theta. In place of sine 1 minus, so minus into 1 minus, right, 1 minus cos square theta. Sine square can be written as 1 minus cos square theta. So in place of sine square theta, we can have 1 minus cos square theta plus 16 pq into p square plus q square cos theta, all divided by again 2 into p square sin theta minus q square sin theta. Okay, let us simplify further. Okay, next minus 4pq minus 2 into p square plus q square cos theta plus root over square root over 16 p square q square can be written as 2 into 2p square 2, so later we can 16 right as it is 16 q square p square q square plus 4 into p power 4, distribute 4p power 4 plus 4 into q power 4, 4q power 4 plus 8p square q square into, wait, so here cos square theta minus, distribute minus, minus into plus minus, minus 1, minus into minus plus, plus cos square theta. So distribute minus, you will get minus 1 plus cos square theta. Already 1 cos square theta is there. So cos square theta plus cos square theta, 2 cos square theta, minus 1. Now 8p square q square, distribute 8p square q square into 2 cos square theta, 16 p square q square cos square theta, still minus 1 is there, distribute, okay now. So 8p square q square into minus 1 minus 8p square q square, and remaining terms plus 16pq p square plus q square cos theta, all divided by same expression 2 into p square sin theta minus q square sin theta. Right. X is equals to minus 4pq minus 2 into p square plus q square cos theta plus root over 16p square q square minus 8p square q square or 8p square q square. So 16p square q square minus 8p square q square or 8p square q square. So 8p square q square can be written as 2 into 2p square into 2q square. So here actually 16p square q square minus 8p square q square, 8p square q square. Again 8p square q square can be written as, can I write like this, 2 into 2p square into 2q square. 2p square into 2q square. It's like 2ab. So plus 8p, 4p power 4 can be written as 2p square whole square. Similarly 4q power 4 can be written as 2q square whole square. So just observe these three terms, a square, b square plus 2ab. So we can write a plus b whole square, write it here. Okay, next. So remaining terms 16 p square q square cos square theta. So we already simplified minus 16 p square q square minus 8 p square q square. So this term already simplified. And last one 16 pq p square plus q square cos square. P square plus q square cos theta. Whole divided by same terms, similar term. So into p square sin theta minus q square sin theta. Okay. Still we need to simplify the square root further. Next step, x is equals to minus 4pq minus 2 into p square plus q square cos theta plus root over. So a square plus b square plus 2ab, a plus b whole square. So 2p square plus 2q square whole square. Next. So next steps plus 16 p square q square cos square theta. Just cos square theta. Okay. Plus 16 pq p square plus q square cos theta. Whole divided by 2 into p square sin theta minus q square sin theta. X is equals to minus 4pq minus 2 into p square plus q square cos theta plus root over. So here 2p square 2q square 2 common. So 2 into p square plus q square whole square. In these two terms 2 common. Take out 2 as a common factor and remaining terms p square plus q square whole square plus here 16 p square q square cos square theta. So in this term we have p square q square and here also we have p square plus q square and this is 16 p q cos square theta. So this term can be written as 4 pq cos theta whole square. See, 4 square 16 p square q square cos square theta. 4 pq cos theta whole square. Now it looks like a square. Suppose a is equal to 2 into p square plus q square. A square b square. Then it's still 2ab. So this can be written. This term can be written as 2 into a value 2 into p square plus q square. B value 4 pq cos theta. Just to verify this term, multiply 2 into 2 4, 4 into 4 16. PQ term, p square plus q square, p square plus cos theta. Yes. Here we have one more identity divided by denominator. So 2 into p square sin theta minus q square sin theta. Now x is equals to minus 4pq minus 2 into p square plus q square cos theta plus root over here 2 into a square plus b square plus 2ab. So a plus b whole square means uh, 2 into p square plus q square a plus b. B value 4pq cos theta whole square. A plus b whole square. Square root get cancelled. So a plus b whole square. See, a square plus b square plus 2ab. So a plus square get cancelled. And the denominator b square sin theta minus q square sin theta. So here a small correction. Here into cos theta. Into cos theta. Here also into cos theta. Okay. So minus 2 into p square plus q square into cos theta, not q square cos theta. X is equals to minus 4pq minus 2 into p square plus q square cos theta plus 2 into p square plus q square plus 4pq cos theta all divided by 2 into p square sin theta. So here we can take sin theta common, take sin theta common, 2 sin theta into p square minus q square, minus. So 2 sin theta common, p square minus q square. X is equals to, see, 4pq common. So here we can take minus 4pq common. Minus 4pq common, negative becomes plus 1, and here minus cos theta, 1 minus cos theta. In these two terms, 2 into plus 2 into p square plus q square common. Here common factor is 2 into p square plus here minus 1, and here minus 1 minus cos theta, here plus 1. So take common and remaining terms 1 minus cos theta. Right? See, here 4pq, here 4pq common factor. Now I am taking minus 4pq common. Negative term becomes positive. So anything not there means plus 1. Here positive term becomes negative minus cos theta. Here 2 into p square plus q square common, 2 into p square plus common factor. So 2 into p square plus q square common, and remaining in here 1, and here minus cos theta. 2 into 2 sin theta into p square, a square minus b square, a plus b into identity, a minus b. So a square minus b square is equals to a plus b into a minus b. So p plus q into p minus q. Still 1 minus cos theta common. Take out 1 minus cos theta as a common factor, and remaining here minus 4pq, here 2 into p square plus q square. So 2 into p square plus q square, it can be written as p square plus q square. So right, it can be 2 into p square plus q square minus 4pq whole divided by 2 sin theta into p plus q into p minus q. So 2 into p square plus q square minus 4pq. Still, is there any identity? Here we can take 2 common. Still we can take 2 common. Here 2 into 2, 4 can be written as 2 into 2. Let us take 2 common. So 2 common means x is equals to 2 into 1 minus cos theta. 2 common, so p square plus q square minus 2 already common, so minus 2pq. All divided by 2 into sin theta into p plus q into p minus q. So numerator to denominator to get cancelled. So numerator to denominator to get cancelled, and x is equals to 1 minus cos theta into a squared plus b squared minus 2ab. So a minus b whole square identity. So p minus q whole square. So a square plus b square minus 2ab. So a minus b whole square. So p minus q whole square. Sin theta p plus q into p minus q. So 1 p minus 2 p minus q get cancelled. And the final expression. So p minus q whole square, 1 p minus q cancel. So remaining 1 more p minus q into 1 minus cos theta all divided by here p plus q into sin theta. So what is the actual expression for x? X is equals to, initially we considered x is equals to, let tan phi by 2 is equal to x. So replace x by tan phi by 2, we need value of tan pi by 2. So tan pi by 2 is equals to p minus q by p plus q into 1 minus cos theta. 1 minus cos theta is equals to, what is the formula for 1 minus cos theta? 1 minus cos 2 theta is equal to 2 sin square theta. So here we have only 1 minus cos theta. So submultiple angle formula. 2 sin square instead of theta, theta by 2 divided by sin theta. Sin 2 theta formula 2 sin theta cos theta. Sin theta formula submultiple angle. 2 sin theta by 2 cos theta by 2. So 1 sin theta by 2 sin theta by 2 get cancelled. 2 to get cancelled. So tan phi by 2 is equals to p minus q by p plus q into sin phi by 2 by, here cos phi by 2 is there, cos phi by 2. We know that sin theta by cos theta, tan theta. Here phi by 2 is there. So what will be the answer? Tan theta by 2, sorry. Tan sin theta by 2, cos theta by 2. So sin theta by 2, cos theta by 2, tan theta by 2. So tan phi by 2 is equals to p minus q by p plus q into sin theta by cos theta by 2, tan theta by 2. Therefore, tan phi by 2 is equals to p minus q by p plus q into tan theta by 2. So option A is the correct option. So the correct option is A.